Hi, hello everyone, welcome to this video. So last time we left off with our tree, and this time I just wanna instance it. What does that mean? Well, that means that we're going to have many instances of this tree, but we're going to reuse the same pipeline. So what we're gonna do is just modify transform matrix. It's going to be huge buffer, right, of our transforms or model matrix. It's better name, well, probably model matrix. We're just going to have many instances of it. And that will basically create the same looking tree, but with different scale, rotation, and position everywhere on the screen. And then I think about instancing it's batched. So what does this mean? Just showcase our result that we're aiming for. To batch, it means it's drawn at once, so it's way more optimized than, for example, drawing every individual tree with a different pipeline, right? Or something like that. So we're going to get started with it. It's not that hard. We just need to create instance buffer, actually vertex buffer, which is going to act as an instance buffer. So let's get started. Well, at it, we can just start with a new type of buffer, and I'm just going to call it this one instance buffer. All right. And since it's kind of same-ish as vertex buffer, I'm just going to copy all of the vertex buffer into an instance buffer, not index buffer. And then I'm just going to rename it. So now I have to think about the properties of instance buffer. We still need WebGPU buffer. So it's complaining here because I use probably something like this. Then, okay. It's called instance buffer, of course. Now the properties, the vertex count is not important anymore, because with the instance buffer, we're going to have chunk of memory, which is in our case 44 kilobytes, right? No, bytes, sorry, reserved for matrix, and then times the number of instances. Instead of vertex count, we're going to have instance count, the number of instances. Size we're still going to need, and this vessel, but here, and since our instance buffer, we're just going to pass any random data to it. So we're just going to say, and where t is unmanaged. So it needs to be unmanaged data. What does that mean? It needs to be type of number, structs, etc. Of course, we need to set this here so that we can work with unmanaged. And we don't have vertex count, we have instance count. So do we need it? No, because we can just read it from the data. So instance count is not important. This is data length, that's true, but it's now size of t. Of course, we have to cast it here. We're going to have a new method here, and it's going to be called create instance buffer. So let's just copy paste lazily. Like I mentioned, it's pretty much the same buffer. I just love to make distinction in my engine to know what I'm dealing with. So it's still t, where t is unmanaged. I always forget about this t here. It's pretty much the same. What we're changing is, of course, size of the data. This again. The usage is absolutely the same. We're just dealing with different kind of data. So yeah, we could have referred to this method and just call it create instance buffer, we could have created the vertex buffer as well, but yeah, I'm just going to make the distinction because I'm used to it, because you might work with different API like Vulkan, DirectX, it might be different, so I usually make these distinctions. Anyway, it's not super important. So here we're just going to say create instance buffer. We're done. Vertex count, no, it's instance count, and that can be just data. Of course, we need to cast it as well. There we go. When updating, once again, we're updating t, but we can update single instance of it, right? So this, to me, I would encourage you to create a method for updating chunks, but for now I'm just going to update single instance, and then we can say which instance, right? Instance index, and by default it can be 0. No, we're always going to pass it because I'm going to mess up and forget about it. So description, I'm just going to get rid of it. Not super important because here it's very obvious what it does. So we don't care about this, or do we? Okay, so real length, there is no real length. This will always be size of t, but we're going to need offset, right? So we have our data pointer, which is now t. Actually, now we just paste t. Sorry, lost here. Okay, so we're going to do it like this. So pointer to our data, size of t, and where is the offset here? Because we need to paste offset as well. Here it is. It's our third parameter actually. So here we can just say, I'm going to do it like the offset, and then I'm going to paste it here, offset. And here it's probably complaining once more because of this, right? We need to cast it. So third parameter is offset, then pointer to data, right? And here I did it like this, and then finally the size. So we're going to update always instance by instance. Of course, when we first paste it, it's going to update the entire buffer. So here what we want to get rid of is all of this related transform. We're just going to have instance buffer, what did I call it? Instance buffer, right? Of matrix, right? 4x4, and then we need to pass float type. So transforms buffer. I should have called everything model buffer, but all right. And then let's go. I'm going to pass it later into the constructor, or actually let's do it now. So we just need this transforms buffer. I'm just going to break it here. Right, we're good. Instance buffer. Okay, I forgot, very important. We need to type here, not here. So that's on me. It should be like this. So I'm not sure what I was thinking, because this should not be on method, it should be on class. All right, my bad. We fixed that. So let's get back to our billboard render pipeline. We have transform buffer. That's good. Still it's complaining because I did something wrong. Yeah. So iDisposable should be first, and then we serve where. iDisposable right here, right? So it's iDisposable where t, and then it's unmanaged. Okay, all right. Easy to get lost here. And then let's go to back to our billboard and the pipeline. Now it's fine. Perfect. So transform we can get rid of here. Then we hit this create resources. We transform. We just need to get rid of this here. Model. Let's get rid of everything here related to transform or model. Here it's complaining because I reused this bind group layout descriptor for some reason, so I'm just going to fix it. And it's not model, it's, I believe this is texture. So just minor fix, everything remains the same. Here it's texture, that's fine. Create bind groups, we don't have anything related to transform anymore. So in a way we're also cleaning this stuff up. And then here, well, this is important. When you find pipeline layout descriptor, the number is now 2 because we're getting rid of this, and then you just have to fix indexes here, and layout count is 2 as well. Of course, we don't have to paste it in our render function, but we have to fix indexes here, right? Because this one becomes 0, this one becomes 1 instead of 2. I think we're almost done here. Okay, good. So what we need to do further is actually describe these attributes. And what attributes do I mean? Well, we need to describe this, right? We already described, sorry, we already described this in our pipeline, but we now need to describe these things as well. So somewhere in our billboard, when we create a pipeline, where are you? We have this create, and I believe there should be another overload with vertex buffer layout. So we're going to need to paste this instead of using it like this, because in our pipeline we did this, right? And then we had overload that takes that information in. So we're going to use this overload. And it might be better set as an array, right? It might be easier to use it. Let's try it like this. So we're just going to change this method where we have vertex buffer layout. It's just easier to use. Then we can use fixed, and we can do this, right? Just reference it. And doesn't need to be a pointer anymore. So I'm just going to go to end, make a column here. So we're just going to paste it in. So we can say vertex buffer layout pointer here now. When we create the vertex state, and the buffer count is not going to be 1. So we're probably going to need to cast it because it takes uint, but it's just going to be vertex buffer layout and then length. And that should work way better. So we're probably going to have to fix some. We're probably going to have to fix some stuff, but let's deal with that when we're there. So now here we just need to describe all of this. So we can paste an array here, vertex buffer layouts. It's going to be 2 layouts, right? So we're going to say position vertex buffer layout. 1 is initialized. Actually, we can do it better like this. Now let's do it like this. But we need vertex attribute. So vertex attributes. Right, we're describing the attributes now. Position. This needs to be array, and we're going to have 3 of them. So this is for our position. What did we have? Color and texture coordinate, right? So we're just going to initialize the first one. And then we can do it like this. Format, this is for position, right? So we're essentially X, Y, Z. Then shadow location is 0, offset is 0, no offset. So then we had the second one. And this is good suggestion. Second one was color. So it's not position here, it's position here. And then second one is color. And then third one was texture coordinates. And this is good suggestion as well, right? Because offset here is 7, right? 3 for position, 4 for color. And that's vertex buffer layouts. We have vertex attributes. Good. And then this is good. So we now need to paste those to our first vertex buffer layout entry. 0. Now this is important. So here it's vertex step mode, and then attributes. Is it complaining? Okay, it needs to be stack allocated probably. So we're just going to say probably needs to be pointer thingy. So because we're working with this low level stuff, so we're just going to say stack alloc and then do this, and now it works. So we're just passing vertex attribute. These are for vertex part of the buffer. Attribute count is 3 and array size is 9. So 3 for position, then 4 for color, that gives us 7, and then 2 for texture coordinates. So now instance buffer layout. And here it kinda, no, this is all wrong. So very bad suggestion. Okay, we're going to need once more this, right? But now we have 4 of them, right? For each row of the matrix. And I'm just going to call it instance attributes. And then we can do this probably in a for loop, right? Because they're very similar. So we're just going to say int I equals So what we're doing with the for loop is just going for all of those 4 rows, right? We're just trying to describe this. We can do it in for loop because it's way easier. So instance attributes, let's go with I, right? That's the first one. And then we just create a new vertex attribute. So this format is good. It's 32 by 4, right? This is vector 4. Shade location, this is good. It's 3 plus I. It textual read that good. Why 3 plus I? Because we start here, right? 3 plus 0. Then we have 3 plus 1 gives us 4 in the next iteration of loop, and then we get to 5 and 6. So this is good. Shader location is good. And then this is also very fine. The offset, we have size of float times 4, right, for our vertex size, and then I. So the first one is going to be 0, the second one is going to be 1 times this, which gives us 12, right? Sorry, 16, and then the third one will give us 32, and that's all good. So we essentially did all of this in one loop because here it's convenient. And I think that's it almost. So did we paste here? We have this, we have vertex attributes, we have instance attributes, so we can just paste it here. So our vertex attributes and our instance attributes. That should be somewhere over here. Oh no, I missed it. So it should be pipeline layout and then this thing. Sorry, let's check here. Shade module, vertex buffer layout, array, vertex buffer. We already created array, so we don't need this. So we're just going to say vertex buffer layouts. It's complaining though. I don't get it. I'm a bit lost. Did I do something wrong? So we have here, we're saying vertex buffer layout. That's good. Shaded module, then pipeline layout. Maybe. Okay, good. And I think we're almost there. We just need to fix a couple of things. So we fix this. We need to pass that transform buffer, and we pass it similar to here, where you pass vertex buffer. It's kind of almost the same, right? It's just at position 1, we pass the transform buffer and transform buffer size. And here it's just a bad formatting, so we need all of this. Just be mindful, it's at location 1 now. All right, so just to explain, what did we do here? We essentially just described 2 buffer layouts, right? One for our layout of our vertices, so this position called texture currents, and then the second one for instance buffer, which is these things over here. Good. All right, it's probably not going to work because in our terrain, sorry, not the rain, our decal from the last time, we need to create that buffer. So I'm just going to do it like this. So we're going to have, so it's going to be matrix 4x4 float transform data, and let's just say that we're going to have 100 of and those, and it needs to be an array, of course. And then we're going to have our instance buffer, and it's going to be like this, right? So maybe I can just here say new, it's more easily readable. So we're probably going to need to first instantiate that instance buffer. We're just going to initialize it. We're going to move this transform. So we can say our transform data 0, right, is equal to all of this. So it's just going to make it look the same as the last time, and then we just need to paste it in. Transform buffer. Actually, I called it instance buffer. I'm just going to recall it transforms buffer. Good. We initialized it, so it means we copied all the data, and in theory this should work. Let's try it. Maybe it works. Hopefully. We have some bugs. Let's fix that. Because of this here. So we're just going to change this to an array. Anywhere else? This one here as well, because we changed the type, and I think that's it. Okay, we have an error, and for me, I'm rendering DirectX. Can I find it? Validation error. Let's see what it does. Render pipeline to 1 is invalid. Doesn't say why though. Let's try to find that error. Validation error. So it means that I probably paid something wrong, but let me quickly check and then I'll get back. All right, what of course I forgot was to actually right here, right? We described this vertex buffer layout, vertex mode, but I never did it for here, this instance, since I totally forgot about it. I'm getting lost between all of these arrays. So we just need to describe our vertex buffer, our layout 1, which is now instance instead of right here vertex, right? We paste these attributes that we have created earlier. Attribute count is 4, and then the size is, we could just, I'm not sure why I did that. It's just 16. Is okay because we're describing matrix. So 4 times, we have 4 times vector 4. So 4 times 4 is good as well, but let's just keep with 16. And then we're done finally. So if I run it now, hopefully it will work, and it does work, which is perfect. Our tree is still here, nothing changed. So what we want to do now is just pass like all 100 instances. So let's try to do that. If we just go to our, where are you? Our decal, which is somewhere over here. We can now do this in a for loop, right? For int I equals 0, I is less than transforms data that length I plus, right? We're just going to do it 400 times, and then we can do math that, sorry, random, random. And then when we translate, we can just say random next double times 64. Why 64? Because I believe it's size of our terrain. We're going to paste in terrain later, but we can do this minus 32, right? Because our terrain was centered, so it goes from minus 32 to 32, something like that. So we're going to do, and this can be next single. We're going to do that on set and here as well. If we run it now, we're not going to see a change, probably. If I try it, because I think we haven't pasted instance count, and that's very true, but at least our tree is somewhere else. There is 100 of them, it's just that we never paste instance count, so let's do that. Now billboard and pipeline, I believe there are 2 places where we need to paste it, right? Because we have one drawing with index buffer and one if not. So where it is here, right? Instead of this one, we're just going to say transforms buffer instance count, and right here as well, and that should do it. Right over here, of course, it will be better to pass instance count here, and if you know buffer size, then you can render that buffer size. And of course you could also use offset, which is parameter somewhere over here. So essentially what I would do is just have instance offset and then instance length, but of course I'm not going to do it because it's not super important for this video. But if I try to run it now, we still see one tree, which is amazing, but all wrong. So it means something is wrong with either instance count or how we initialize the data. So let me quickly check. It's 100, so that's good. But our instance buffer, sorry, not instance buffer, our decal, we're creating all of this, right? So all of them should be different. 0, 0, 0, no good. Of course, it's no good because I forgot to say I here. Ah, there we go. There we go. We have all of our trees. So now we have a couple of issues here. First of all, we should position them correctly. That's easy to fix. That's not that hard. But also we have this alpha issue, and that's because of the sorting, right? We should probably sort this correctly somehow. Of course, I'm not going to do sorting in this video. So what we can do is we can get rid of alpha regions. So that's also useful to know. How do we do it? It's very easy. In shader, in our billboard shader, we can just say something like this: var text color. We can move it right over here. Text color multiplied, but here we're just going to have one small condition. If text color is less than, this is too much, let's say 0.2, we can discard that fragment and it's never going to be rendered. So essentially this is a return statement, so it's just never going to have any color. So if we do go now, we don't have this weird stuff with the alpha, and it's all good. So how do you fix that? Well, you don't, unless you want ordering. So that's always going to be something that you have to work on. If you don't have alpha regions like we have here, it's not an issue, right? But here we have alpha regions, so that's why it's complaining. But anyway, let's pick that height. It's going to be very easy, because all we need to do is pass our terrain to our decal. Because if you remember, in terrain we had all of this data, so I'm just going to say here terrain. And I believe in terrain, let's just check properties. They're not exposed, so we're just going to quickly expose all of terrain properties that are relevant for us. So it's going to be height data, so we're going to need it. So this just becomes public height data, right? And it can be just get private set property. All good. So we just need to change it here and here as well. And we also need this terrain width and terrain height. Okay, the terrain width. Sorry, not height, actually length. So we're going to need that data as well. So we can just say here terrain width and then terrain length. Oh, good. Just a bit of refactoring for our terrain because we need these properties. All right. So if we go back to our decal, we just need to find our height, and that's very easy to do now. So we're just going to do this. We're going to have float x, which is equal to this, and float z, which is kind of same. Z and x. But we're going to use them as indexes in our terrain height data. So we're going to have float height, and it's terrain, not get height, height data. So how can we do it? Very easily, right? We know z, and if we imagine terrain, so if we imagine our terrain something like this, and then having these rows, and we say, okay, you know what, z is going like this, and then x is going like this, right? So we can find an index by knowing a row, which is just z times, right, number of columns, which is x. So it's basically row times width. So if we do like, row times I, or better yet z, right? Row times z times width will give us index, and then we just need to do plus x. So basically, let's say that our I is 2. So row times I times width will place us here somewhere. So index is going to start at 64, it's something like 128, and then to find x we just need to add x to it. So let's say that x is 3, and then we know we're looking somewhere over here in our terrain. Okay, so basically we need, and we just need to cast it down, z times, so it's not super precise, you might want to round it or something else, but for me this is enough. So we're just going to do terrain width and then plus x, and of course we need to downcast x. And if I pass height here, and then I just want to add a bit of offset, because if it's just height, our terrain might be, our tree is going to be in terrain, so that's no good. We need a bit of offset, and you can always like play with this offset. And then it's complaining about something because I haven't passed terrain here yet. So let's do that. Let's run it, and it broke. Because of course this is now negative. All right, because of this. So we're just going to move this, because this needs to be positive, and then afterwards we're just going to make it negative. Okay, should work now. All right, we're almost there. It looks like I made a slight mistake. So here it seems like it's a bit offset, right? This should be somewhere here. Let me try to fix that and just see what might be wrong. So what's wrong is, it's not, our terrain is not 64, it has 64 fields, right? So it's always +1. So what I want to do here is just do this. Now let's create an index actually, like terrain index, and then let me see how I fixed it. So we're going to have z times terrain width +1. And I don't need actually here this, and then our x +1, and then we can take that index in. It's not terrain index, it's actually maybe, let's leave it as is. So now if I take a look, yeah, it's a bit better. Yeah, that looks about right. So you can still tweak it. The offset with just 64 didn't work, so we needed to resize it to 65, but it works. It's because of the previous bug. Anyway, it works. So that's how you can do instancing, and it's very important, and I'm going to showcase why. So let's just inspect this in RenderDoc, and I already captured a frame. So if we go here and we need texture view, so this is our texture, and the view is not super important, it kind of looks ugly, but whatever. So here, right over here, right, you can see that we draw all the trees at once. And that's usually not the case. I'm not looking at any cubes here, but these are for cubes, and we draw them one by one, right? And then here, when we're using instancing, we draw immediately all the trees. Otherwise, all of these trees would be drawn one by one. So that's why instancing is kind of really, it's what instancing is good for, like having same objects which kind of look the same. You can scale it, you can rotate it, you can change the position of it, right? So our scale is the same, but you could essentially change the scale as well as rotation, but it's not, the rotation is ignored here pretty much because it's a billboard. But you can change those properties and then have many instances of the same object, and that's very optimized, right? So you can draw hundreds, thousands, tens of thousands of objects very quickly. So that's why I wanted to showcase it, and it really seemed fitting here. So the question is, what if we have different texture? Well, then it gets a bit more complicated, and you're probably going to need another render material. But if you have same material, which is same pipeline, you can create many instances of it. All right, that's it for this video. Maybe quick recap what we did here. So first of all, we just created a buffer that can hold that instance data, but that buffer, even though I call it instance buffer, is actually just a vertex buffer. So yeah, you're just passing vertex buffer, which you describe a bit differently, and we did that in our billboard render pipeline, right? We now pass, instead of one, we pass here two buffers. The first one describes our vertex data, the second one describes our instance data, which is this instance buffer. We just needed to describe it, right, the attributes, and then we needed to set the second one to instance buffer. This is what makes the difference, right, this step mode. And these are just descriptions, not super important. And in our shader, all we had to do was, if we go here, we needed to paste these attributes which act as our instance buffer, and then we needed to create our camera, and we're good. So that's it, really quick recap. So for the next time, what I want to do is just create an enemy and maybe animate an enemy. That would be fun. So it's probably going to be similar to our decal. We're just going to animate it, have some enemy walking towards us, and then we'll see what we'll do next time. Okay, that's it. If you enjoyed the video, please maybe like, comment, subscribe, and until next time.